welcome to a new edition of the Heat Treat podcast. Today we have two European guests all the way from Germany. They're actually based in Düsseldorf, from SafeChem. We got Stefan Lukowsky. Can you raise your hand, please? And we got Chris Tivnan. They both are, Stefan is European Sales Manager for SafeChem, and Chris actually based in Boston, American Sales Manager. And today we're gonna talk about pre-cleanup parts and post-cleanup parts on heat treatment applications. But first of all, how are you guys? And if you just could give us an introduction of the company you work for, your background, which I see that it's quite outstanding, so the audience can actually know the speakers of today.
Sure.
I don't know who wants to start.
I can start. Hey, thanks a lot, Carlos. Great being here with you today. I can give you a little background on SafeChem. SafeChem was founded, it's a subsidiary of the old Dow Chemical Company. SafeChem started up in 1992 as a branch off. We sell precision cleaning chemistry that goes into vapor and vacuum degreasers for precision cleaning and metal parts. Some of our customers range from aerospace to heat treatment to medical device companies, even into small little metal plating shops. I had the opportunity to come on to SafeChem this past January. Previously, I was a product manager for a US distributor. So I took over the North American market, handling Mexico, Canada, and the United States, and look forward to the challenge. I think in the United States, this is the future based on EPA regulations and with the chlorinated solvents. So modified alcohols are really the future going on in the US right now.
Right. Yeah, also thanks for having me, Carlos. So my name is Stefan Lukowsky.
Very welcome, Stefan.
Yeah, I'm with the company in August for 15 years. Yeah, so time flies, and for some reason I'm loving to talk about cleaning. Yeah, I think you won't find so many people talking about that because washing dishes at home is also not so sexy. Yeah, I'm the European sales manager, so I'm traveling around the world consulting customers on their critical challenges that they've got. And yeah, maybe worthwhile to mention that in the US, from our previous mothership Dow Chemical, probably one of the most famous brands that we sell is Dow Clean. Yeah, so that is something that typically customers know most of the times more than SafeChem as a company. Yeah.
So thank you so much for that introduction. So today we're going to talk about the cleaning process of the part, why it's important. When we talk about heat treating, we're always talking about metal, microstructure transformation, the quenching, heating up, automation. But what are the most common issues that heat treaters experience when the parts are not clean? Why is it important to have good cleanliness of the part? You just talked about two very important industries, which is the medical and the aerospace, right? When we are in other industries like the tool industry or automotive, it's important. But I would assume when it's going to a plane or let's say to a hip prosthesis or something like that, cleanliness is just a must. But can you go deeper into that comment?
Yeah, absolutely, Carlos. I give you a couple examples, but it's critical in medical device companies. It's critical in any type of application because the failure of parts, if you have cross-contamination when it's going to go into heat treatment, it's only going to increase your operational cost because you have failures. But let's talk about, in particular, a medical device company. If you don't have the proper cleaning and it's not thoroughly clean and you have residue on a particular part, for example, say an endoscope, and you have residue on an endoscope, that endoscope's eventually going to get into somebody's body and cross-contamination can occur. And you could have an issue, a serious health issue, and that's a big liability for a tool manufacturer. So cleanliness is the utmost important. And I'll give you another example in aerospace or avionics. There's companies out there that do parts for the F-35 fighter jet, the premier fighter jet in the world right now. If you have any cross-contamination in any of those parts, you're likely to potentially have a catastrophic failure in that $35 million machine. So the cleaning process is absolutely critical, really, in any type of manufacturing process. So that's what SafeChem is able to do. We have a variety of different solvents working in North America, working in vacuum equipment that comes out with the best type of cleaning process you can possibly get.
So when we talk about cleaning, what are the contaminants that usually come with parts? Are we talking about oil? Are we talking about carbon, dust, metal residuals, which are maybe other soaps? Or what are the main contaminants that come into the part that we want to, wash out on the cleaning process?
It's probably something, Carlos, that cannot be answered like straight, right? Because
Right.
contamination wise, we have seen everything. Yeah. So, but typically,
what's the weirdest thing you ever seen?
The weirdest thing is probably that sometimes, and that's not like the typical contamination that you would foresee to come in a degreaser or something, but we have also heard about, some towels or some wipes that go through cleaning machines and cause a big headache. But that's probably not the point that we want to discuss about. If you ask about weird things, when we ask about weird applications, then it's the perspective to take, whether you talk about critical contaminations like some waxes, or some really difficult fluoro type of waxes that are then attached on the surface that are really difficult to remove, and where we also need to say that not all our solutions will be able to clean anything off from a part. But if we speak about heat treatment applications and in particular cleaning before and after heat treatment applications, then most of the time before the heat treatment applications, we see that the parts have been worked through a process, right? You had any turning, milling, stamping, whatsoever, and depending on where in the process chain you sit, you may have also some corrosion protection additives on it, You have maybe some interim cleaning steps on it. So there is a variety of things that you have on your part that is disturbing the heat treatment process, and actually where the cleaning comes into place is that you want to remove those contaminations on the surface so that you can get the maximum out of the heat treat application. So here we need to see that there are different heat treatment applications that then also require themselves a different quality that is desired on the surface, so that the heat treat application is working good. But also what we see more and more coming is that after the heat treat application, when you have the parts going into the quenching fluids, that you also in a way contaminate the parts. And suddenly the final customer is not wanting to get an oily part necessarily. And there you can really see a crazy space where people with some microscopes are counting particles on the surface, where you can really go like in easy cleaning applications, but you can also go into very complex cleaning applications, and that also makes our daily life so manifold.
Yes, and I have come across with from very basic cleaning of parts, just immersing water and maybe just spraying on it with hot water, right? And that's basically. But if the application it's going to have a post process, right? We just do not want to remove the oil. We want to have it pure clean. And now there's two sides of cleaning the part. Before entering the heat treat process, to avoid any other contaminant to go into the heat treat process, right? Like wax, you mentioned wax, or maybe I'm assuming sand if we are on a foundry or anti-roster, let's say, right? If it's a post machine. But then when you quench the part on oil or I don't know, maybe polymer, I assume, or some other, you're doing a post wash after the quenching of the quenching process. What are like the two different ways important to do a pre and a post? What do you see, and what might differ the washing process when it's a blow and press? Should it be done on the same washing system? Should we use a different washing system? Are we attacking the same things? Are we attacking different things? Do you have a comment about it?
Yeah. So actually, we see it from a different perspective. I mean, first of all, the customers, before I go into that, for the customers, obviously always the decision between cost and quality in a way, right? So normally, if you do heat treat applications, cleaning is often perceived to be like the needed devil, right? So that's something that you must do to get the heat treat application done properly, and therefore you would normally want to have that done as cheap as possible. But that might come with a compromise, yeah, if you don't choose the right cleaning application and technology. Yeah. So if we talk about high quality cleaning, and again, that obviously also depends on the heat treat application that you run through. Yeah, our principle typically starts that we look on what is the contamination on the surface and how to choose the right cleaning process based on the variables that then come into that heat treat application. And I missed to mention also in the process before the heat treatment, from the stamping, turning, milling, most of the time you find also here oils, yeah, or aqueous lubricants, yeah. So those waxes, dust, that is normally like the little part of that show that needs to be cleaned off. But what we actually do is that we choose the right cleaning fluid based on, yeah, the contaminations that are coming in. Yeah, as here you can really define the outcome parameters, which also includes, yeah, quality and cost. And if I may, I would give you an example. We are based here in Düsseldorf, yeah, and one of the most famous aqueous detergent manufacturers known on the world is the company Henkel, yeah, that is producing here in Düsseldorf also aqueous cleaners. And they've had some academic person working in Henkel, yeah, that really did nothing else but really looking on how can I define the right cleaning process, yeah, and what are the variables that play into that, yeah. And what Mr. Sinner has identified is that cleaning is actually the result of 4 different parameters, which is time, temperature, mechanics, yeah, and what did I miss?
Heat?
No, that was temperature, time, mechanics, and oh, yeah, you see.
Fluid?
I give you that example.
Pressure.
That we'll figure it out, Carlos. So I give you that example. When you wash your hands, right?
Right.
After you have exchanged the chain on your bike, right? And you have oily hands, yeah? Then you can go to the tap, yeah, and wash your hands. And depending on how much pressure you give on it, yeah, to wash your hands, and how much soap you attach, yeah, you can increase the temperature, yeah, then we reduce the time, yeah, that is needed to get the desired result, a clean hand, right? And accordingly, you can either, yeah, rub your hands harder to take less soap, yeah, in the same period of time to get that cleaning result achieved, right? Or you simply, yeah, you take cold water and take ages to rub your hands without any soap. Yeah, these are the variables that normally always are yeah, in correlation to each other. So when you reduce the time, then you need to increase mechanicals or chemistry, yeah, and accordingly, when you increase time, then you can reduce something else. So these factors are always in correlation with each other, and that also applies to the cleaning process in the industry in a way, yeah, where typically time is money, yeah, capacities are already given, yeah, so you need to manage a certain capacity that needs to be cleaned so that you can wash your parts that you need to do the heat treatment application. And then on the other hand, the temperature is somehow applying based on the process you take, either because the metal working part is only exposable to a certain temperature. Normally in heat treat applications, not that big a deal, right? But then you have the chemistry that is requiring some certain criteria on what maximum temperature you run. Also then temperature again is relating to environment, and you rather want to have lower temperatures somehow for the environment. So you come back to the cleaning in mechanical perspective, which is the cleaning machine, right? And the chemistry then is the variable that can then make you really taking an influence on the decision. If you choose the right cleaning chemistry, then either you can reduce the investment in the mechanics, like in a car, mechanics typically is like you can have everything in, the question is just what the available budget is. Or if you take the most out of mechanics and chemistry, you may make more out of the time that you will need then to get the parts cleaned. So I'm sorry, Carlos, I'm running you now through that big journey of the world of cleaning.
It is, and just would like to now to talk about the difference between commercial heat treat job shop, right, and a very big company, and your sales guys. So I assume you have visited many shops in Europe, in America, which are very different markets, but running heat treatment process. But what is the main difference between a commercial shop owned, let's say, for like a family company, right? What is recommended for them, which they don't have this super massive budget, but they still have cleaning needs? And when you run into very big companies, state-of-the-art, brand new companies that they have all the budget in the world when they're opening a green place and they have the new technology, what will be like the advice or the solution that you think will suit best for a family heat treat shop? It doesn't have to be small, but let's say middle size, and a very big company. How would you address each one?
Yeah, Carlos, that's a great question. In the past few years or so, there's more and more European vacuum equipment people moving into the United States because they see a need for, in North America with the EPA regulations, more and more people are moving to modified alcohols. The big benefit, and it's affordable for all manufacturers really, even the small mom and pop facilities, because typically what these facilities are doing now is they have the older technology equipment, which is an open top degreaser where they're using a chlorinated solvent, and the exposure level and the drag out rate from these solvents adds up pretty quick. With a vacuum equipment, your solvent usage typically is reduced by 90%. So if I have particular accounts out there that are using, they have an open top degreaser, their budget on solvent, this is on the high end, is about $250,000 a year. Well, they're looking into buying a piece of equipment, the return on investment, and this can work from the high end, big budget customers, all the way down to metal plating shops and job shops. What we do is we educate them on the return of investment. They invest into maybe $110,000 or $150,000 vacuum equipment, and we look at what they're using in solvent on an annual basis now. We can run the numbers, and after 2 to 3 to 4 years, they're going to have the machine paid off based on the usage of chlorinated solvents they've used in the past. So we try to educate them on overall cost and performance. So hopefully that answers what you
I might have one addition to that, even also in terms of the real difference between the job shops and the in-house companies, and I would imagine that also is somehow attached to the question that you've had before. Typically the main difference is that a job shop does not know the parts coming in, right? So if we say that the cleaning chemistry or the technology should be evaluated based on the contaminations coming in, and then you choose the chemistry accordingly based on the contaminations, then the job shop actually does not know necessarily the contaminations coming in, because they get parts from everywhere around, right?
They have, they can just get a new part tomorrow that is totally different to the past yesterday. I mean, it's not a continuous process, it's not a continuous part, same part. They have very, very different part numbers with different metals, that different shape, different density. So that is, when you run into a high volume company, well, it's easier to do testing with the same part, and then just become a master on it. But when you have a very wide difference of parts running every time, you have to have a standard product, a standard process that can fit most of them.
Right. Yeah. And that's really the main difference. Customers that get the same parts every time, they qualify the processes, they take that one decision, that's typically good. The job shopper normally that needs to give out good prices, good quality. They don't know necessarily what are the contaminations coming in. So that's really one of the most challenging tasks, to find here the right process.
And now let's talk about the different cleaning methods and considerations, right? I have lived it on personal experience. There are customers that come and say, I need my part fully clean. And actually working with a Japanese company, and they're very into cleaning of the parts, and they are requesting that the parts should be fully cleaned. It's a automotive application, right? Only for aesthetics, I don't know. It might be to avoid contamination. It's not a critical part to have fully clean or aesthetic, but they just are into cleaning. I do oil quench, right? But how would you address a customer with a cleaning needs? What are the different cleaning methods, which I assume they're different? How would you land a customer with a specific need? How would you introduce them to the cleaning of metals? Advanced, right? Not only submerge into water or just do basic cleaning. What is your approach on that? You mentioned return on investment, right? Yeah. But you have to find the method and then say, this is the right method for you, and then give the price to it, right? But what would be like the method of choice depending on the application?
Yeah, good question, Carlos. And we have a process that we go through. It's typically initial meeting with decision makers, the environmental engineers, process engineers at the particular prospect that's looking for a better solution. We typically take it step by step. We get a copy of all their current SDSs that they're aware of, so we can find out what's actually coming into the system. And then we've also partnered with a number of OEMs, equipment manufacturers throughout the US, throughout Europe. And we're able to, once we do the initial step of processing all the SDSs, we give it to our chemists here in Dusseldorf for analyzing, and they can come up with a recommended stabilizer package, test kit, and proper solvent. Since we do have a variety of stabilizers, we have a variety of test kits, and we have a variety of solvents based on the particulars that each customer has. Each customer is absolutely different. There's a lot of variables that go into it. So once we process that, our chemists come back and say, okay, this is the direction we think we're going in. Then we can contact some of our equipment partners, and we can start the next processes where we have this particular prospect, put some parts together, soiled parts. We send them off to the equipment manufacturer. They clean the parts in their equipment. They process it, send it back to the customer, and they can analyze the parts themselves to see how clean, if it met their specs. There's certain specs that some customers have. There's subcontractors for automotive, subcontractors for Raytheon that have particular Boeing specs or Ford specs that they have to meet. And once we finish this process of sending it to the equipment manufacturer, they clean it, send it back. the customer can see if it meets the specs that they're under.
Should we take an example, maybe, Carlos? Because
Sure.
also you drawn something so that we can also get some more color here onto that picture and make the people understand what a journey could be. You talk about quenching oils. Maybe let's take that as an example, because probably every heat treater knows about quenching oils.
That's like the way of quenching of choice. I mean, when we talk about quenching, most of the people quench in oil right now.
Right. Yeah. And let's take that, and then let's take another example, and let's talk about the, how do you say, heat treat salts? Is that proper English?
Yeah. Salts, right.
Right.
It's becoming more popular all over the years.
Bad for us, and I will explain you in a second why. Actually, we now take it only on those two examples. Obviously, there are typically more contamination, and you need to see the whole picture. But to keep it simple, when you have a quenching oil, then typically that is a substance that is not liking water. Yeah, it's a non-polar substance that is loving oil actually. Yeah, so it's a substance that when you bring it together with water, it will always separate. Yeah, that is an application where you could say, when you want to clean a quenching oil off with water, actually you need to attach something into the water, yeah, so that you can emulsify the oil into the aqueous solution to then clean that off, right? Whilst on a solvent application, you have also a solvent being non-polar, or depending on what kind of solvent that is. Yeah, you have also some solvents that are more polar and then can also bring those polar contaminations more in a solution. But when you then take a solvent, that will give a solution with the oil, yeah, and that makes the cleaning process much easier. Yeah, unlike you have now a salt. A salt is not liking oil. Yeah? It's a polar substance that likes water. Yeah, and here, when you dissolve or want to dissolve a salt in solvent, that will not work. Yeah, you can try hard, you will not get the salt off dissolved in a solvent. So here you need water to dissolve the salt and then clean that contamination off, right? I really think that's the major critical question, to look into the contaminations, find out what the mix is, to then see into which direction we go. And if you really have the time as a company to run those cycles, then there is even cleaning technology available where you can have both. Yeah, the solvent and water in one machine. Yeah, so that you can clean off the whole spectrum of the world. Yeah. Which actually, to answer your question, what is the best for a job shop? Yeah, when you don't know what's getting in, yeah, that might be a solution for those guys. Yeah, that they combine the best of two worlds to make that cleaning process efficient. Yeah.
And now I just would like to add, because yesterday I had an audit by a very big company, and right now with the trend that the big companies are going to zero emission. They're going very environmental, because well, especially in Europe, right? You're Europe guys, so to go electrical cars, and I had an audit, and one of the questions was if we had a plan or a strategy in order to eliminate waste, chemical waste, and how to treat it. And even if you're a big company or you're a heat treat shop, the big companies are going to audit their suppliers on sustainability and environmental, right? So I believe this is where your company can help the most, customers, because they're heat treaters, they're metallurgical engineers, but we're giving CO2 emissions, we're having chemical waste, we need to recycle, we need to use a product that will last longer in order to produce less waste or throw it to the environmental. Oil is a big thing, right? Because you cannot recycle it. Salt you can recycle. What can you tell us about your chemicals washing? How you approach to that? I assume the return of investment is to have a bigger lifespan, a longer lifespan of the product, to use less chemical, or even if it can be recyclable. I mean, what can you tell, or what can you advise those heat treat shops that are going to start to get audits on environmentals, or they need to have a plan to eliminate waste?
Right.
Sorry, but because I believe that's where the world is going right now. It's going to have, we're going to see a big push in the next 5 to 10 years, just going on how to eliminate waste.
Yeah, excellent point, Carlos. You already brought up a few points. You know, it's funny that the United States is probably about 15 years behind where Europe is. Europe made these changes 15 years ago for sustainability reasons and hazardous environmental issues going on with open top degreasers, which are predominant in the United States right now. Europe really doesn't have any left. They've all switched over to sustainable vacuum systems. So for example, in the US right now, there's a lot of aqueous or water-based chemistry being used. That's a huge impact on manufacturers and on the environment for a number of reasons. Shorter bath lives, where they have to change out the aqueous bath more often. So they're dealing with that waste. And they also have wastewater treatment issues that they have to comply with. So they use a lot more water in their local area, and they're impacting the wastewater treatment. I mean, they're putting chemistry into their wastewater treatment to meet all the specs, but going over to vacuum systems, what we're doing is having very limited exposure levels, almost nothing. What we're also trying to do, we work with our chemists, and as we mentioned earlier, we look at the oils and lubricants that are coming in. So we come up with the best stabilization package and solvent package to prolong the bath life in these systems as long as possible. I know in Europe, I think there's a few customers that haven't changed their bath out in maybe decades. We've had a lot of success in the US as well. So we're extending bath life. It reduces the overall cost. We're saving the manufacturer a lot of money, and we're reducing the impact on the environment. So those are the big goals, and that's why we believe that SafeChem is the thing of the future in North America.
You know, the thing about that topic is that you really need to look into the whole process chain, right? I mean, people think water is green, and let's do that job with water. But if you need to add chemistry into a process to make that process happen, then that might not be green anymore. Yeah? And really, the topic is always based on the contamination, obviously. Yeah? That's, I think, is really that takeaway that I hope the audience will get here. And we're not saying that this is like solvents is versus water, because actually it depends really what you've got. Again, if you have salts, yeah, water is really the best solvent, if you will, in that case, that you can have. Yeah, and also if you have aqueous emulsions, yeah, then this is something that you better clean in water. But then on the life cycle, yeah, if you see when you clean oil in solvent, yeah, as Chris said, besides the bath lifetime that you can achieve, yeah, and certainly decades is not a guarantee that we would claim here, but that it's possible to achieve that is the one thing, but also the ongoing consumption. You know, the enabler is the technology of the machine, yeah, so that you have an incorporate distillation unit where you can always reclaim the solvent in a cycle. And let's speak about gallons here, because we talk mainly to a US audience, yeah. When you clean off 100 gallons of oil, yeah, by distillation, what you can achieve depending on the chemistry that you have and also the oils that are cleaned off, yeah, but you have between 1 and maybe 20% of cleaning chemistry waste in the waste stream. Yeah? So it means 100 gallons of oil is between 1 and 20 gallons of solvent. Yeah, so that produces between 101 and 120 gallons of waste. Yeah, so that is the waste production, and then you have the chemical spend is like 1 to 20 gallons depending on what you choose for. Versus water, there is a rule of thumb where we say to clean off 1 gallon of oil with water, you need 1 gallon of soap, detergent, right? To
Oh, really?
emulsion, right?
Okay.
So 100 gallons of oil is 100 gallons of soap, and probably you can also optimize here, yeah? What I want to say is look into the overall life cycle, and then you can see that here solvents are a much greener solution. If we speak about that context, obviously, yeah, and that's really what we have highlighted here for decades already when our company was established, that we tried to always show also the solvents in a wider context. Yeah, it's about risk management, how to use the chemistry in a safe way, in close equipment, yeah, and also educate the customers on how to handle the chemicals. Yeah, and then you can really also attend the mission on driving the sustainability further and beyond. Yeah. So,
Guys,
great.
Thank you so much. It's been great talking about the future, right? Chemicals. Before we close the show, did we miss something, or something you would like to add regarding the cleaning process, chemical pre or post cleaning? Did we miss something, or do you want to touch base on something else for the audience?
I just want to make one point, and because we discussed about aqueous cleaning and solvent cleaning, one of the main differences between using an aqueous detergent and a solvent is what we call surface tension. The solvent product has a much lower surface tension, where when you're dealing with small metal parts that have small little blind holes, it's imperative to get rid of all the residue, all debris that's in there. So the solvent has a much better capability with a lower surface tension to get into those blind holes and remove any type of debris, as we discussed earlier. In aircraft parts and medical device parts, it's imperative to have no residue behind. So that's why we think more and more people are switching over to solvent technology. All medical device, really, all aerospace are really moving in that direction, because the cleanliness is only getting tighter and tighter in North America.
Thank you so much.
What I might want to say is that I really respect the job of heat treatment. Yeah, I mean, we come in as cleaning experts, and we are certainly no specialists about that job. And if I see really the expertise on that topic, that is really superb. Yeah, also what we respect is that the topic of cleaning is getting more important. Yeah,
It is. You're right.
Rising and also problems occurring more and more with also the heat treat applications improving. Yeah, so we say that also new technologies mean new challenges. Yeah, so it's really nice to be now somehow part of that market. Yeah, I mean, if we look into the literature, we can see that obviously cleaning has always been a topic in the heat treat industry, but what we definitely see is that it's getting more and more focus. And that's great to now combine here the world of cleaning with the world of heat treatment.
Now, we talk about the world of cleaning and the world of heat treatment. We went very technical, more than I expected. But now, you guys been in business for quite a while. And you mentioned, Stefan, at the beginning of the podcast, that washing the dishes was not very sexy. But when we talk with engineers like yourself, we get very passionate about these topics, right? We learn this in school, we learn this in the lab, in companies. We solve a lot of problems that they don't appear to be as sexy as working on fintech or startups, you name it. But you have had a very successful career. I'm looking at your CV. Your careers were actually in the army, right? So I bet there's a bunch of other stories. But I always like to close the podcast with some experience or some advice that you learned. It doesn't have to be about cleaning process or history in your professional life that you would like to share with the new guys. You Stefan, you told me that you've been 15 years in the business already. You look very young, right? So I assume you had a lot of mentors, a lot of teachers. But I would like for each of you to share something that you learned, not about chemicals, but about business, relationships, how to succeed in your professional career that you would like to share with the new engineers. We always talk about metallurgical engineers, but you're in chemicals, right? With that guy that study materials or chemical engineering. What would you like to share with those? What would be an advice that you would like to have been given when you started and you chose this path?
Right. Yeah. Maybe let me start, because I know that Chris, he's the most experienced guy, and when I'm out with him, he can tell you stories the whole evening. So that's now your choice, Carlos, when you are going to end this podcast. Yeah, we can take that for another 3 hours then, obviously. But what I may say is, I've canceled chemistry at 10th grade in school, and still I work like 15 years now in the chemicals business. And you just highlighted it, and that's probably like also the motivator, the drive for their business, is that when you have a passion for something, yeah, then follow it and you can do it. I'm certainly not an expert in chemistry. Yeah. We've got like so many chemists here around.
Well, you sound like an expert, I can tell you that.
Thank you.
You sound like one.
Appreciate that. Yeah, but that's like, it's you're interested in something, and then you can also learn it, get into it, and then you will also dive into something that you might not have released another way. Yeah, certainly I had someone that brought me into that space, because my father already started working here, and when he said that there is an apprenticeship job posting open here at SafeChem, my first answer was no, because it was chemistry. Yeah, but on a second thought, it was like, hey, back then my father was working 15 years for the company. Now that's 30 this year. Yeah. But back then, when I started to think about that, it was like, hey, it's a good company that he's working for when he's working there for 15 years. Yeah. So forget about chemistry and let's give it a try. Yeah. And then you develop the passion, and then you also bring that forward in your career. And all I can say, I mean, I'm so bad at cleaning as well. My wife hates me for that, So maybe if that is something that you would like as an answer, then I can hand over to Chris.
Thank you so much, Stefan. It's been a ride. Congratulations, and we want to encourage more people to come into the industry, like the leap of faith that you took. Thank you so much, Chris. One of one of your big stories. What can you share with the new generation?
Well, I'd have to have about 6 beers with you and the Riverwalk down here on the Rhine tonight to really get into them, But anyways, the big thing is with the SafeChem team, we have such a strong team. The sales team, the technical team, we all stick together. And as I mentioned earlier, I was in the military. We did standard operating procedures. We followed processes. That's how I kind of take the approach to customers. I use my team. We scrutinize all the different variables. Every customer has different variables we go through, and we give our best approach to the customer. I try to put myself in the customer's seat. I pretend I'm the customer and say, what is the best thing for me? And I give them my honest opinion, what the best process and what the best thing go. And I give them a couple options. And let them make the decision. But we do a real good, we do our homework and before we make a proposal.
Thank you so much, guys. Guys, it's been a ride talking to you. Stefan, Chris, all the way to Dusseldorf. Good afternoon to you guys. Good morning for me. But it's always very cool about learning about technologies. I believe this is where the future is going. Environmental sustainability. Less waste, and it will have to do a lot with chemistry, right? So you guys keep what you're doing. You're doing great, and just would like to remind the audience that we're uploading monthly podcasts with experts on the subject like Stefan and Chris, people who are passionate, reviewing products, reviewing processes, so we can actually understand better what's going on the heat treat industry, the heat treat process. Thank you so much, guys, for being here, and we'll see you next month on another episode of the Heat Treat Podcast. We're on LinkedIn, we're on YouTube, we're on Spotify. So give us a like, guys. Go like this. Give us a like.
Awesome.
To the channel, and see you next month.
Awesome. Thank you.
you.